All right, and then here it is. Okay, so let's just start with the trig, the 6 trig values right there. All right, it is, let me go back to the so we have 13 pi over 3. We have negative pi over 3. And then we have 750, right? Okay. And when you guys look at this here, let's see here. All right, 13 pi over 3 is equivalent to what? 4 pi, right? And then pi over 3, right? Right. If you put 4 and 1/3, right? That's the mixed number, right? But I split it up. Why? Because 4 pi is 2 times around the circle, correct? All right. And then what happens here? And then there's pi over 3. So you're pretty much just looking at the pi over 3 portion. So a pi over 3, all right. If you just get the sine and cosine, so sine of pi over 3 is radical 3 over 2. The sine of 13 pi over 3 is equal to radical 3 over 2. The cosine of 13 pi over 3 is 1/2. Okay. From that point, you're going to do the tangent. The tangent, let's call it theta, which is pi over 3, is equal to radical 3 over 2 divided by 1/2. I would like for you to show work on this. Okay, so radical 3 over 2 times 2 over 1 is cancel, cancel. This is radical 3. Okay. The cosecant, which is the reciprocal of sine, is 2 over radical 3. Which if you multiply both sides by radical 3 over radical 3, it is 2 rad 3 over 3. Secant theta is equal to 2. Tangent theta is equal to 1 over radical 3, which if you multiply both the top and the bottom by radical 3 is radical 3 over 3. I think this year, I would like for you to show your work on the algebra, so the rationalization, okay? Please show your work with that. Okay. All right. That kind of tells me like where you are in this whole thing. All right. Okay. Negative pi over 3. If theta is equal to negative pi over 3, that is equivalent to what positive value? 5 pi over 3. Okay. And if you get the sine of theta, cosine of theta, the sine of theta 5 pi over 3 is negative radical 3 over 2. The cosine is positive 1/2. So it's very similar to what you did with the first one, right? Tangent would be, so if you did it here, you're good here. It'll just be negative radical 3, right? Because a negative divided by a positive number, right? There's a positive right here, is negative. What about cosecant theta? It's negative 2 radical 3 over 3. What about secant? Just positive 2, right? And then the tangent, sorry, cotangent, my bad. I did that like here. This is cotangent. Cotangent is equal to radical 3 over 3, negative radical 3 over 3. All right. And then 750 is the same thing as pi over 6, right? 750, right? 2 times around the circle is 720 degrees minus 30. Sorry, so 750 minus 720 would be 30 degrees. So 30 degrees is where we're at. 30 degrees, the sine of theta is equal to 1/2. Cosine of theta is equal to radical 3 over 2, right? Tangent of theta is equal to 1/2 divided by radical 3 over 2. if you multiply this out, cancel, it'll be 1 over radical 3, which is radical 3 over 3. Okay? All right. And then cosecant is equal to 2. Secant is equal to what? 2 over radical 3, which is 2 radical 3 over 3. And then cotangent theta is equal to what? Radical 3. All right. Not too bad, right? Sorry, it's a little messy, but yeah, we good? This, and this. All right. All right, let's go to the actual wave now. Let's go to the waves here. All right. So again, you guys could pick and choose which values you want to put, or maybe put the pi over 2 here, and then every 2, so pi, right? 3 pi over 2, and then right here would be 2 pi. Again, whatever you guys need to do. Sign starts out, and you can even change this if you want to change the 2 to 1. It's fine. You can change the values, but here's the 1. We start at 0. This is pi over 4 then. Pi over 4 is 1, right? Then pi over 2 is 0. Negative 1 would be, negative 3 pi, sorry, negative 3 pi over 4 would be negative 1. All right. Sorry, I'm thinking about tangent, my bad. Let me do that again. Pi over 4 is radical 2 over 2, right? What's radical 2 over 2? It's like 0.57, something like that, right? So it would be like what? Pi over 2 is 1, right? And then back at 0, back at negative 1 here, and back at 0. So it looks something like this. Yeah, something like that. Kind of makes messing this up. Yeah.
Did you have to change the X value?
I didn't know, but I just did. But you didn't have to. Okay, so I'm confusing myself. Sorry. And then it should be something like this. And then it's something like that. Okay. I just the spacing of it is all weird. Actually, I think you kind of do pi over 2, because you know how this is like you move over twice to get negative pi over 2, and but you only get 1 here, right? So I think you should yeah, switch them up a little bit. All right. Cool. All right, any question on that? And then at cosecant, what do? You draw the asymptotes here, right? You just draw the asymptotes at the zeros, right? Right, then what? You put a dot here, and then it goes up, right? Goes down, goes up, It goes down. Okay. And for, again, this, right, make sure you guys write some table of values here, like X and Y, 0, pi over 4, pi over 2, 3 pi over 4, pi, so on and so forth, and then figure out the Y's. Okay, so it'll be 0, and then this will be like 0.57. This will be 1. This will be 0.57. This will be 0 again, so on and so forth. Okay, the table of values are important, especially for the parent function. The cosecant, just know the cosecant, what the cosecant does. All right, so again, base everything around the sine function. All right. Any questions on that? You good? All right, number 2 is the more difficult one. All right, we have 3 as the amplitude. That's pretty easy. But then once we get the 2x, then life is good. Okay. All right, so you may want to give, so it'll be like 3 cosine 2x. That's what the y is equal to. So you may want to get the cosine 2x first. Try to kind of get that going a little bit. So you want to graph that first. So let's graph this first. So y equals, let's ignore the 3. Let's equal just y cosine 2x. And you might want to put values of like pi over 4, pi over 2. Actually, maybe even more, like pi over, so I should put pi, I should have started with pi over 6. Let's start with the whole thing. 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, so on and so forth. What's 3 pi over 4? Then what is it? 5 pi over 6, and then pi. All right. So then cosine of 2 times 0 is 0. The cosine of 0 is 1. Cosine of 2 times pi over 6 is pi over 3. The cosine of pi over 3 is what? 1/2, right? Cosine of 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. All right, so they start graphing these. So 0, 1. Then pi over 6 might be like right here, which is 1/2. Pi over 4 is 0, right? Okay. And so you'll notice that, let's see here, pi over 2 is at 0. So I should have pi over 3. Anyway, I'm just going to kind of rough it a little bit, but it's going to do something. It's going to be a lot quicker, right? There's going to be a lot more waves here. Okay. All right. Then if I want to do the 3, I just have to extend it to 3. So it would be, the zeros are the same. So always keep in mind what the zeros are. And then graph the amplitude. So from here, go to -3 right here. It'll do something like this, so on and so forth, okay? Then what does the secant do? The inverts it. So again, we're going to put the 0, like, again, I'm just estimating here. I'm kind of like dogging it because for the sake of time, if I was really like accurate, I would. But I would put zeros here. Oh, sorry, asymptotes here. And then graph the parabolas going up here from here. Make it a lot easier. So a graph like this would suffice getting this. It kind of tells me that you know your stuff. All right. Then with the shift, you know, you might want to go right 4 up 3. All right. So just, you know, like just go right 4 up 3, you know, kind of thing. And then just try to just guesstimate from here, you know. There's this right. I know it's kind of tough, but just try to like estimate from here. Yeah.
For the test, could we have like the x-axis and stuff?
Here?
For the test, could we have like different x values?
Yeah, you could just cross it out and just, yeah, you if you want to cross it out. Yeah. And then I can give you also, I can give you another graph too. You can do that. Yeah, I think it looks crazy, huh? But I like it, okay, because it shows me that you know what you're doing. Like it shows me like all the shifts and, you know, it just shows me like that you know what's going on. Okay, so, but like, don't like start scribbling, going, hey, this is a 4, right? This is a 4, you know, and it's like, come on, you know, like you guys have to kind of, but I can kind of see like the thinking behind this, okay? So, yeah, all right. Cool, any questions on that? We good? I know it's crazy, but you might want to just graph it on Desmos and then we'll go from there. All right. Okay. Yeah. Yeah, you could start with the 3 cosine 2x. That's fine too. Yeah. I just was trying to like do an extra step on top of that. But yeah, looking at this right here, this is beautiful to me. All right, this is beautiful. Okay, it looks, it's like there's a lot going on behind this whole thing. Okay, so yeah, yes, especially with the different colors and stuff like that. Yeah. So yeah. All right, we good? All right, next thing is, okay, find the equation of the cosine function that has an amplitude. So this is pretty straightforward for most of you guys, because you know that what y is equal to a, and then cosine b x minus c plus d. And if you guys understand, like the whole semester, this whole semester, we've just been dealing with transformation. All right, a lot of it is we've looked at different functions, right? And then we're just looking at, and then we're focusing on different transformations. All right, once you guys get this, you will have to get like limits in calculus and everything like that. Once you guys understand the functions aspect, you will be fine when it comes to calc. All right, so y is equal to, what's the amplitude? 3/5 cosine, and then the b we'll get later. What's x? What's c?
-4.
So it's just -4, good, plus or minus, sorry, -3. Okay, so that's not too bad, right? Now the b is the hard part, and remember they give you the period of 3 pi. So it's what? You just have to go 2 pi over b. So the period, remember in that one slide I gave you, the period is equal to 2 pi over b, right? What's the period? The period is 3 pi. So I replace that here, and I multiply both sides by b. So b times 3 pi is equal to 2 pi. Divide both sides by 3 pi. And what do you get? B is equal to 2/3. So the final answer is y is equal to 3/5 cosine 2/3. And then what? X minus 4 minus 3. And that is your answer. Okay? All right. Let's go to those problems that I put together for the pre-calc exam here. You guys need me to post that up here? Okay. Yeah. All right. All right. We go with this? All right, here we go. A lot of terminology here, but let's go to problem like number 3. Okay. All right. And this is I gave you 7 and 8. Well, let's try number 3 here. All right. Number 3 is if 4, 3 is a point on the terminal side of angle theta, find the exact values of each of the 6 trig functions of theta. What the hell? What? Don't go crazy with this, okay? This is not that bad, all right? So now let's go back. Do this right here. Actually, I'm gonna, here we go. I'm gonna write on this, but that's fine. All right, so what you want to do is you want to graph the point 4, 3. Okay, graph the point 4, 3. So 1, 2, 3, 4, 1, 2, 3. Okay, this is theta right here. All right. Now, they're asking for what? They're asking for all 6 trig functions, right? Okay, so this is 4, this is 3. How do I get this side right here? What is it? No. How do I get this side right here? How do I get the hypotenuse? How do I get the hypotenuse here? This is 3. This is 4. What? Pythagorean theorem. Good. Okay. So it'll be what? 4 squared plus 3 squared is equal to c squared. So this is what? 5 right here, right? Correct? Okay, so now, because and so what? So to get the sine of theta, that's what? 3 over 5, right? Opposite over hypotenuse, right? How do you get the cosine of theta? 4 over 5. What's the tangent of theta? 3 over 4. Okay. Cosecant of theta? 5 over 3. Cosecant of theta? And cotangent. All right, you guys are geniuses. Right, this is it. All right. Okay. Cool. So these questions look, oh my God, it's so crazy, but Jay, you're gonna kill me. No, okay, it's not as bad. All right. And so try to simplify it, try to kind of like, just one step at a time, look at the question. All right. And remember, what's the terminal side? Terminal side, initial side is the beginning side, right? It's this side right here. Terminal side, this is where it ends. Okay, that's all it is. All right. The terminal is the ending point, the ending side, the initial side is the beginning. All right. So as we're going from the initial axes, you're moving up. Okay, from that. Cool. All right. Okay. Let's go here. Number 4. Find the exact value of each expression. Do not use a calculator. All right, here we go. So why don't you guys try this? It's not hard. All right. Go to the tangent, look on your table, and get the tangent of pi over 3. Okay, what is the tangent of pi over 3? Radical 3, right? Tangent of pi over 3 is what? Radical 3. What is the sine of pi over 3? Radical 3 over 2. Right? What is the cosine of pi over 2? Cosine of pi over 2? 0. Okay, so all you have to do is just multiply these out. This is what? Radical 9 over 2, which is 3 over 2. And minus 0 would be, so this 3 actually. Okay, we good? All right, so again, you guys are answering right now. This is knowledge check. This is the end of this is the end of fall semester. This is the test I gave out. So this is like a 5th knowledge check that I gave out. So you guys are answering, you guys are starting to answer these questions. Okay. Probably like, these two questions might be, okay? All right, find the exact value of, why don't you guys try to figure this out? I'll give you guys a minute or two. This is a good question. All right, remember it's the inverse, so focus on this is the composite function, right? The inverse cosine of negative radical 2 over 2. Focus on that first. Give me the degrees, or give me the radians on that. The inverse cosine of negative radical 2 over 2. What is the inverse what would that be? What would
3 pi over 4.
3 pi over 4, not so, no, not there. Remember, you're getting the radians. 3 pi over, you're right, 3 pi over 4, thank you. Sorry, sorry, thank you. It was 3 pi over 4, what else? There might be another answer. What would the other answer be? Not pi over 4.
5 pi over 4.
5 pi over 4. What?
What about 7?
Not 7 pi over 4, why not? Okay, so let's look at the unit circle here. All right, here we go. Now, how did Geo get those answers here? All right. Look at the filled out unit circle right here. All right. Remember, it was looking for what? The cosine of, so the cosine is the x value, right? And it's negative what? Radical 2 over 2. So you're pretty much looking at where is x negative? It's right here, right? It's right here at 3 pi over 4 and at what? 5 pi over 4 right here. Okay, we good? Everybody understand that now? All right, so if I'm looking for this question right here, what is the inverse cosine of negative radical 2 over 2? All right, you're looking at where is cosine, the x value, negative? It would be in quadrants 2 and 3. It would be 3 pi over 4 and 5 pi over 4. All right, then it asks what? Okay, so here's the question that it asks, right? It asks, okay, so it goes tangent and then cosine radical 2 over 2, right? So now we can replace this with the tangent of 3 pi over 4 and the tangent of 5 pi over 4. We're gonna get two answers here. All right. What is the tangent of 3 pi over 4? Negative 1. What is the tangent of 5 pi over 4? 1. So these are your two answers. Okay. All right. You know, I hope that you guys are feeling good about this because again, like these are good questions that like you guys are gonna get. And you're gonna keep, and once you guys get the vectors and polar graphs and stuff like that, again, these will all kind of come into play. Right? Cool. All right. Last question, and then we'll call it a day. All right. Here we go. All right, here we go. Let's go with. All right. Okay, so it says find tangent of theta if, here we go, there's a bunch of conditions here. Cosine theta is equal to radical 2 over 2, and the sine theta is equal or is less than 0. Negative 1. Gosh, Mr. Genius here. All right, good. Okay, so you're thinking about two ways, okay, right? The x value is what? Positive radical 2 over 2. Where is it positive? Which quadrants is cosine positive? 1 and what? 4, right? Because that's the x value right there, right? So let's look at the unit circle again. See, radical 2 over 2 is positive here. Radical 2 over 2 is positive here. So it's either this one or this one. What's the other condition though? The other condition is what? Where the sine value is less than 0. Right? So it has to be in quadrant 4 because that's where the sine value is negative. Okay, so if you look at that right here, right? If you look at that right here, the sine value, the y value is negative. right? So it would be 7 pi over 4. Okay, all right. You get this? All right, you feel like you're getting, so, all right. Try this next one. All right, try this next one. Let me change this to this here. Let me change the cosine value. Why don't you guys try this? Radical 3 over 2, and the sine is greater than 0. How about that? Why don't you guys try right now? Okay, you try it yourself. Let's try to figure out, find the tangent of this right here. Okay, all right, I want to make sure you guys kind of get this. And yeah. This is not on Canvas. I'll find it.
Like A or B.
This is for sure to do. And I'll find add like that. Yeah, okay. But again, like, I don't want you to like, I want you to kind of like,
Nine is gated.
that's what I'm trying to do. Like, because for the most part, like the waves are memorization, right? But this is like, okay, like my mind has to kind of like think about this and apply this stuff. And that's where I'm trying to get your stuff.
Wouldn't it be nice to see this?
It is.
When I got.
All right.